Hi everyone, welcome to the final page of our review. We are finally going to finish up. So I need you to grab a piece of paper and a pencil and also your calculator, and we are going to get started. Here we go. Alright, so number 26 and number 28 are about symbols. And we're going to have a section on the final exam, the online portion, where I need you to match symbols to the different concepts that we've learned. And one of them is going to be X bar. X bar is the sample mean. And sigma is the population standard deviation. But I need you to know all of these different symbols. We're going to have a section for matching. The sample mean is X bar, the population mean is mu, the sample standard deviation is S, and we said the population standard deviation is sigma, like a 6 that's kind of been whooped over by the wind. Sample size is N, and our linear correlation coefficient is R, and the margin of error is E. We've talked about these all semester, a lot of these since the very first month of school. So these should look pretty familiar, but you can pause the video and write these down if you need to review those a little bit. And again, these will be on the online part, so you can go back and look things up if you need to. You just need to know the different symbols. Okay, so moving on from that. The next thing we're going to do is this linear regression, and you're going to be using your regression analysis calculator. So if you would go ahead and find that. We have entering GPAs and current GPAs of 10 different students that are in grad school. And what we're going to do is enter all 10 of those here in the regression analysis calculator with commas. So pause the video for just a moment and enter those. Okay, now that we've got those entered, we click on plot points, and you can kind of look at these, and they sort of look like they're relatively around this line. Because everything's between roughly 3.5 and 4, we can't really say that we have anything that really looks like an outlier. Nobody in this group really looked like they were making like a 2.4 or anything that was really outside the norm here. And you'll notice that we have the equation, we have R squared. We're going to write down all of those. And I want you to look carefully at this equation. It's not y equals mx plus b. We're used to y equals mx plus b. But this is y equals b plus mx. It's like fixed plus variable cost, fixed plus variable change. And so I usually write it backwards. I'm used to y equals mx plus b. So when I write mine, I may write it down like the calculator says, but then I immediately write it as y equals mx plus b, because that's what we used to write it as when we learned Math 1, Math 2, Algebra 1, and you're used to slope plus intercept. I can't remember if I asked you about slope on the final exam or not, and I don't really even remember. Okay, but we have the equation, we wrote it down. This was to 1 decimal place. I wrote this to like 3. You're probably fine if you wrote it to 2. Write down R. Okay, we need to go and look up our table value, and I forgot to write it down, but we counted the number that we have here in our table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's go see how many that we have in our table, our linear correlation table. Oh gosh, did I close that? I did close that. Okay, give me just a minute. Okay, so here we go in week 6, table of critical values. Go down to 10 and over to the first column. I guess I could figure out how to make this bigger. Here we go. Go over to the first column and it says 0.632. Perfect. Write that down. We always use the first column unless you're doing something that's like a medical thing, like pharmaceuticals. So 0.632, and then you compare that to R. R is bigger than your table. Bigger is better. If R is bigger than your table, like I wrote up here, if R is bigger than the table, use the equation. R is bigger than the table, use the equation. So we're going to use the equation, plug 3.4 into the equation, and we get a GPA of 3.39994. Nobody has a GPA of 3.39994. GPAs are to one decimal place, so this person has a 3.4 GPA. Okay, great. Can we predict the GPA of somebody that has a 2.4? No, because people don't go to grad school that have a 2.4. All these people have GPAs between 3.5 and 4.0. 2.4 is too low, it's too far away. We call that the era of extrapolation. That's kind of a cool little word. Okay, R squared was 0.67. It was 0.6685 something something. Okay, explain what that means in a sentence. Okay. Slide this down. Okay, what that means. The minimum that I want you to say is about 67% of the variation can be explained. That's the minimum. If you go on to grad school, you will have to say about 67% of the current GPA can be explained by the linear relationship between entering GPA and current GPA. And you can say the whole sentence. But for me, if you just say about 67% of the variation can be explained, I'm good with that, because that's what R squared means, is how much is being explained. All right, and so that takes care of all of our review. I think that's about it. And study hard, and I will see you at the final.